Yeah, hi guys. We'll start the class in 5 minutes. Just wait for 5 minutes.
Sure.
Hi, welcome to the demo class DevOps with AWS. Am I audible?
Yes, yes.
Okay.
Yes.
Thanks for the confirmation. So, actually, my name is 𝐬𝐽𝐬𝐧𝐢𝐬𝐧𝐢. I have 10 years of IT experience and I got certifications from Kubernetes, that is a certified Kubernetes application developer, and AWS solution architect, and also got certification from Azure, that is Azure DevOps specialist. So I'm the trainer for this course. The course duration is 2+ months. For today's agenda, we'll see what are the contents we are going to cover in this 2+ months course. Okay, and we'll have some brief introduction about SDLC and introduction about the cloud computing. So this is today's agenda, and so while doing this course, I will get the support from us, like at the end of every module, we'll provide assignments and we'll conduct mock interviews and we'll help to prepare a resume. So this is the support from us. Okay. So coming to the course contents, the course is DevOps with AWS. DevOps with AWS. And from DevOps point of view, we are going to cover all the tool stack, whatever we need as a DevOps engineer. All the tools we are going to cover in our course. Here we are going to cover Git, Jenkins, Docker, Kubernetes, Ansible, and then Terraform, Okay, so these are the tools we are going to cover from DevOps point of view. So when we are dealing with Jenkins, we are going to discuss about Maven and SonarQube. Okay, once we completed with the DevOps tools, we'll start with Amazon Web Services. So from Amazon Web Services, so we have many tools from Amazon Web Services, but as a DevOps engineer, so whatever the tools we need, we are going to cover all the tools, all the services from Amazon Web Services. Here we'll cover the services like the EC2 and VPC, S3 buckets, and elastic block storage, ABS volumes, RDS, relational database services, and IAM, identity and access management, elastic load balancers, okay, CloudWatch. So these are the tools we are going to cover from Amazon Web Services. So to start our course, there is no prerequisite. So even from the guys who are from non-IT, they can easily understand our course. But we need a Linux basics. Okay, so to work as a DevOps engineer, the prerequisite is only the basics of Linux, not in-depth knowledge. Linux is required. The basics of Linux is sufficient. Okay, so by considering this, we'll start our course with Linux basics. Only basics, we are not going to cover in depth about the Linux, okay? Because Linux is again is separate. No, we don't need that much of knowledge from the Linux. But we need only basics. So this is the plan. So we will start our course with the Linux basics. So the basics will cover up to 1 week. For 1 week, we'll have only basic classes. So after that, we'll start with the remaining DevOps tools. Okay. So before learning these tools, so why we are learning these tools is to know the purpose of learning these tools is so we must have some knowledge about ACLs. So have you know what is the SDLC? Have you heard this term previously? Any one of you, please?
Yeah, software development life cycle.
Yeah, thank you. So SDLC is nothing but software development life cycle. Okay. So we have different methods of SDLC to complete the end-to-end flow for any project. Okay, to start any project, we have to implement any one of the software development lifecycle model. We have different models like waterfall model, and nowadays most of the organizations are going with the agile methodology. Okay, so whatever the SDLC model we have, whether it is a waterfall model or agile methodology, there are some common phases. So in SDLC, so this what this SDLC define is a software development life cycle defines the end-to-end flow of a project from development to the deployment of it. Okay, so the development is nothing but the initial stage. So initially we have to get the code for our project depending on the requirement. So once we have the code, then we have to work on to the code, and finally we have to deploy the code. So once we deploy the code, our project will goes to live. Okay. So in this process, we will have different stages, like we'll have plan stage and development of the code development. And once the code is available, we are going to test the code. And so after this, we are going to deploy. So we will have some other methodologies. considering only these are the different stages we have. Okay, so here the main motto of any software organization is to develop an application. So project is nothing but development of an application and maintenance of an application like IRCTC, Amazon.com, any. So like this applications. Okay, so like these applications we are going to develop. So means in our application, so we will have different features. So if you consider any e-commerce website, you will have a login feature, you will have products information. Okay, under products again you will have different categories of projects. So all these we are considering as a features, different features. Login is one feature, and electronically related products is one feature. So fashion related product is one feature, like that. For in our project, whatever the features we have, we are going to divide. Okay, so means for our project we need plan. What is our requirement? Okay, so the plan will get from the architects. Architects will architects will get the plan. Okay, so with the help of architects we are going to get the plan for our project depending on the requirement. Okay, so in the planning phase we are going to get what the features we need for our project. Let us consider we have five features. Five features. Okay, so five features. These features will be like it depends on the type of the project we are creating, we are trying to develop. Okay, so once we got the plan, from the architects, in the next phase, depending on the plan, our developers are going to develop the code. Okay, so code development will happen in the next phase. Okay, code development will happen once we have plan for our project. So nowadays, most of the organizations are using Agile methodology. So in the Agile methodology, what we are following is we are going to follow sprint model. Okay, so to develop our code, we are going to follow sprint model. So what is this sprint is? One sprint is it is like one sprint equal to 2 weeks or 10 working days. Okay, so like that, it's slightly different depending on organization. It will differ. Okay, so in the sprint model, what will happen is so at the beginning of every sprint, there will be sprint discussion. Okay, and in that sprint discussion, the developers are going to decide what are the enhancements they have to do for the coming sprint. So we'll have different development team for every feature. So here we considered five features, right? So for every feature, we can consider a separate development team. So the respective development team will work to enhance the code depending on the requirement for that particular sprint. Okay, so like that, sprint discussion will happen at the beginning of every sprint. Okay, so once the sprint is completed, they will release the code. So let us consider on sprint one. Means sprint one means at the end of the sprint one. So we are going to get version 1 code from our development team, and on sprint 2, so we'll get version 2. Means there will be some enhancement on every sprint. Okay, so we are calling these enhancements as the different versions. Okay, so means at the end of every sprint, we'll have different versions of the code to maintain these versions of the code. Okay, we have different teams, right? So from all the development teams, I will get different versions of the code. What we have to do is we have to maintain this code. So to maintain this code, to maintain the different versions of the code, whatever we are getting from our developers, so we are going to use version control systems. Okay, so VCS is nothing but version control systems. So what these version control systems will do is, these version control systems will maintain all the versions of the code from our developers. So we'll have different types of version control systems like Git, and we have Bitbucket and SVN. So like that, we have different types of version control systems. So with the help of these version control systems, we are going to maintain the code from our developers. So in our project, if we want to start the project, the first tool we have to consider is the version control system. What this version control system is doing, with the help of this version control system, we are going to maintain the code from our developers. Okay, so that is the reason why we are learning Git as a first tool in our course. So Git is a version control system. Version control system. So with the help of the Git, we are going to learn how can we maintain the code from the developers, and how can we work on the different branches for different development teams, how can we merge the code. So these code related maintenance work we are going to do with the help of version control system. But as a DevOps engineer, we are not going to write any code here. What is our work here? So here our work is maintenance of the code from the developers. So with the help of any one of the version control system, we are going to maintain the code from our developer. Okay. So means we will have the code ready in our version control system. Always the updated code from all the development teams will be available in version control system. Okay. Now, once we have the code, ready, we have to work on the code. So once we have code ready, we have to build the code. Okay, we have to perform some operation onto the code. We have to build the code. So build means, again we will classify this build stage as we are going to compile the code. Okay, so compile means we will get human readable code from our developers. We will get human readable code from our developers. We have to convert this into mission readable code. Okay, so for that we are going to compile the code. So this is the first stage under build. While we are trying to work onto the code, first of all we have to convert our code into mission readable format. For this purpose, we are compiling the code. Okay, so this is one of the phase under build stage. Okay, we have to compile the code, and compilation is success. We have to test the code. So test means we are going to perform like a unit testing. We are going to validate the test cases for our code, and if testing also fine, we'll do the packaging. So these are the different stages we can see under build phase. Okay, so once we package the code, we are going to get artifacts for our code. We get artifacts. So once we have the artifacts, we can deploy these artifacts into the deployment servers. So once we deploy, our project will come to life. Okay, so here under build phase, to perform these operations, we are going to use some tools. So we are going to use the tools like CI/CD tools. CI/CD tool. CI/CD is nothing but continuous integration and continuous deployment. Okay, so under continuous integration and continuous deployment, so we will have the phases like a compilation, testing, packaging, and a deployment. So these are the different stages we have. So once we have the code in our version control system, to work onto the code, we are going to use a CI/CD tools like Jenkins. So we have a CI/CD tools like Jenkins and TeamCity, Bamboo. So these are the different types of CI/CD tools we have. So out of this, Jenkins is very popular. Most of the organizations are using Jenkins. 90% of organizations are using Jenkins only due to its simplicity, and it has a good community support. And Jenkins is rich in plugins, and it is a open source. Jenkins is a open source. Like that, it has very good features. So that's why Jenkins is very popular CI/CD tool. Okay. So with the Jenkins, with this CI/CD tool, what we are doing is we are going to work onto the code. Okay. So that is the purpose why once we completed a Git, we are going to start with Jenkins. So in the Jenkins, what we can do is, so we are going to create a different types of projects. So like a freestyle project, and we create a pipeline project, and we are going to create a Maven project, folder project. So different types of projects we'll create with the help of the Jenkins. Okay. So uh, in the Jenkins, all these build operations. What are the build operations we have? We have compilation, testing, packaging, right? So all these build operations will be performed in the Jenkins with the help of other tools like Maven and SonarQube. Jenkins cannot perform any work directly, so Jenkins will take the help of Maven and SonarQube to work on it. So this Maven is a build automation tool. Okay, so Maven is a build automation tool. So with the help of the Maven, a build automation tool. So with the help of the Maven, so Jenkins can compile the code. Jenkins can validate the test cases. Jenkins can package the code. Okay, Jenkins will perform the packaging also. So it means we'll get artifacts with the help of the Maven only. Then what is the Jenkins doing here? What Jenkins is doing here? So Jenkins just coordinate each and every process in this SDLC workflow from development to deployment of the code. Every process will be coordinated by the Jenkins, but Jenkins will take the help of other tools to perform any operation. Okay, so Jenkins will take the help of Maven to get the artifacts. So Maven is going to create the artifacts. Jenkins cannot create the artifacts directly. So Maven will help to get the required artifacts. Similarly, Jenkins will use the help of SonarQube. So what this SonarQube will do is, SonarQube is a code quality to do the code quality analysis. So we can use SonarQube. So this is a static code analysis. Yes, any doubts?
మామ కొంచెం మెల్లగా మాట్లాడు మామ.
He's gone mute. If you are not talking, he's gone. Okay. So this SonarQube is a static code analysis. What this SonarQube will do is, it will check the quality of the code. Means the code whatever we are getting from our developers, that code is as per the standards or not. Okay, so that basic checkouts, basic code analysis, code coverage will be done by the SonarQube. Okay, so Jenkins will take the help of SonarQube, and Jenkins will perform the required static code analysis onto our code. Okay, now so we have artifacts, right? So these artifacts we can deploy. So once we deploy the artifacts, our project will go to live. So under deployment phase, okay, under deployment phase, again we'll follow two ways. Means we can directly deploy artifacts. Okay, this is one way into our deployment servers. So we can directly deploy our artifacts, and instead of deploying the artifacts directly, we can use containerization tools for deployment purpose. Okay, so we so here if we use a containerization tools, we are going to get images. Okay, so images to deploy. So these are the two ways for deployment. While deploying our artifacts, we can deploy the artifacts directly, or we can deploy the images. We can use the images for the deployment. So in the first way, if we are trying to deploy our artifacts directly, so no need of containerization tools, no need to use any other tools. So as artifacts are readily available, we can deploy the artifacts and our project will go to live. Okay. Otherwise, if you want to deploy images, if you want to use images or to deploy to make our project live, we have to use containerization tools. We have to use containerization. So why we need to deploy images? So we already have artifacts. Why can't we deploy artifacts directly? So why we are going for images is, so here if we are deploying artifacts directly, what will happen is I will get some environment configuration issues. So in any software organization, we will have different types of environments. Like we'll have dev environment, we'll have SIT, we'll have UAT, prod. Okay. So like that, we will have different environment. So in the dev environment, dev people will be there, development people will be there. They will develop the code as per the requirement, and they will test the code in the development deployment servers, dev environment deployments. Okay, so here dev team will be there, so development team will be there. They will test the code. Initial testing of the code will happen in the dev environment. Okay, so let us consider for our application the prerequisite. There is one prerequisite. Okay? The prerequisite is, so we need Java 11 for our application to run seamlessly. Okay, to run our application seamlessly, we need Java 11. As a development team is directly testing the code, they will know what is the prerequisite because they are going to write the code, right? So they will know the prerequisite, and they will try to maintain the required configuration in the dev environment. So the code will work without any issues in the dev environment. So the code will be successfully tested in the dev environment because the prerequisite is Java 11. So development team knows the prerequisite. They will maintain the required prerequisite, and the code will work without any issues. So once the code is a success, so dev team will get the sign off. He will get the sign off to move that code to the SIT environment. Okay. So in SIT environment, again, so who will be available in SIT environment? So SIT environment is a testing environment. QA people, testing people will be available. Okay. So let us consider in the QA environment. So in QA environment, again, we'll have different set of deployment servers. So in QA environment, there is no Java. They are using Java. Let us consider. Okay. Okay. So if that is the case, we got the same code, whatever the code we have on dev environment, the same code we got into SIT environment also, but there is a change in the environment configuration. Instead of Java 11, QA team has Java 8. So what will happen to the testing? The code is definitely going to fail. Okay. So once the code failed, and then again the testing team is not going to give sign off. No sign off. We are not going to get any sign off from the testing team. Okay. So no sign off will be there. Means the code is not going to be moved to next environment. Okay. So again, this QA team will notify the code is not working as per the requirement. Then development team has to investigate the reason for the failure, where the code got failed. Okay, what is the actual reason? There is no change, no issue with the code. The issue is with the environment. So to identify that, again, it will take some time. So some discussions will happen. So this is to rectify that. It is a time-consuming process. They have to spend some time to rectify this. After identifying the root cause, they will do the configuration changes, and they can again test the code. So that is a different one. Okay, means so even though there is no change in the code, the same code is working in one environment, but it is not working on another environment due to the change in the environment configuration. Okay. So like that issues, we'll get many issues like this when we are trying to deploy artifacts directly. Okay. So if we are deploying the artifacts directly, so like that issues will get, and ultimately what will happen here is the production will be delayed. Production will be delayed. If the production is delayed, it is going to affect the organization. Okay, so production is delayed means our project will not come to live in the expected duration. Okay, so like that we have some issues if we are directly going with the artifact deployment. Instead of that, instead of deploying our artifacts directly, if we go with images, if we go with containerization tools, okay, so what will happen is, so irrespective of the environment configuration changes, irrespective of the environment configuration changes, so if we use images to deploy, so whatever the configuration we have in the environment, okay, so our images will be deployed successfully without any issues. So why it is going to happen is, so here what is the image is, image is nothing but it is the combination of application code, okay, and the required binaries and libraries and other dependencies, whatever we need, other dependencies. Okay, everything will be bundled into a single package. That is nothing but image. How we are going to get this image? To get this image, we have to use containerization. Okay, so with the help of the containerization tools, we will get images. So what is this image? Image is nothing but the application code and required binaries, libraries, and whatever the configuration prerequisite we need, everything will be bundled. Okay, everything will be bundled in the image. So if we use image, okay, so for testing for deployment, so if the image is successfully worked in dev environment, okay, if the image is successfully worked in dev environment, then no need to bother about the environment configuration changes for the other environments, because the image itself will have all the required prerequisites. So what is the prerequisite we considered here? Java 11 is the prerequisite we considered for our application. So this will be embedded in image itself. Java 11 will be embedded in image itself. So if the required prerequisite is embedded in image itself, so this image will be tested successfully in dev environment. Okay, once the image is successfully tested in dev environment, we will get the sign off. Okay, the same image will be deployed in QA environment also, SIT environment also. And even though we have Java 8 in SIT environment, no need to bother, because the required Java 11 is available in our image. So deployment will be success. Okay? So no need to bother about the deployment. Our code will be successfully and deployed. Okay. So like that. So once we got successful deployment, we'll get the sign off, and after the testing, our code will move to the other environments. Okay, so like UAT and prod environments also. So if we are going with images, if we are going with containerization tools, so no need to bother about the delay in the production. So okay, production deployment will happen in time. We can expect in time deployment to the production. Okay, so it will increase the productivity of our organization. So like that, we have many advantages with the containerization tools. So what are the containerization tools we have is, so Docker is one of the popular containerization tool, and we have Kubernetes. So these are the popular containerization tools. With the help of these tools, we are going to create the image. We are going to deploy the images to our deployment servers. That is the reason why we are learning Docker and Kubernetes in our course. Okay. So if you see, once Jenkins is completed, we'll start with Docker. So Docker is a containerization. So in the Docker, we will learn how can we create containers, how can we create images, how to write the Docker files, and we are going to cover about the Docker Swarm and so Docker networks, Docker volumes, all the advanced topics also we are going to cover under Docker. So similarly, we have Kubernetes. So Kubernetes also like a containerization orchestration tool. So Docker is a container tool, and Kubernetes is a containerization orchestration tool. Okay. So what this Kubernetes will do is, if we have hundreds of containers, okay, so maintenance of these containers to achieve high availability for our application is difficult with the Docker itself. So for that reason, we are going with the Kubernetes. Okay, so in the Kubernetes, we will try to get the high availability for our application. Okay, so we'll implement we are going to create parts and replication controllers, deployment objects. So like that, different objects will create, and we'll try to achieve high availability for our application under Kubernetes. So that is the reason why we are learning Docker and Kubernetes. So once we done with the Kubernetes, we are going to cover with the Ansible. This Ansible is configuration management tool. Ansible is the configuration management tool. So we have different types of configuration management tools like Ansible. We have Chef. Okay, we have Puppet. Like that, we have different types of configuration management tools. So Chef and Puppet are the oldest configuration management tools, and Ansible is the newest one, and it has very good features. So it is simple to learn. We can easily implement Ansible for our configuration management work. Okay. So why we are learning this Ansible is so here with the help of Ansible, so we can automate our infrastructure if we have any repeated tasks to perform. Okay, so like that tasks we can easily automate with the help of the Ansible. So let us take one example here. Let us consider we have 1,000 servers. Okay, so onto all these 1,000 servers, so we need to do some patching. We have to perform some patching activity. Okay, so let us consider I have Java 8. I have to upgrade to Java 11 on all our 1,000 servers. Means I want to do some patching activity. Okay, so to work to do this patching activity on one server, so let us consider is taking 30 minutes if we are doing manually. Okay, so this patching work is taking 30 minutes per server. Then for 1,000 servers, how much time we need if we are doing manual operation? Okay, so for 1,000 servers, so we have to spend 500 hours. So in 500 hours, what we are doing? In these 500 hours, what we are doing? Just we are doing the patching work. Okay, so means unnecessarily we are wasting the time. We are spending much more time for a simple patching work if we are doing this manually. Okay, so instead of manual operation, so if we are going with configuration management tools, okay, so there will be one controller, there will be one controller manager. Okay, so what this controller manager will do is it will connect it to all 1,000 servers. Okay, and this controller manager will run a script, will run one script on all servers, all servers. Okay, if it run the script, so what the script it is going to run? It is going to run the script to do the patching activity. Okay, so to run the script it is taking 30 minutes, right? So in 30 minutes in all the 1,000 servers, okay, in all the 1,000 servers, the patching activity will be completed if we are going with the configuration management tools. You see how much time we are we are saving here. Okay, if we are doing the manual activity, we have to spend more time. So instead of that, we are going to automate the process to reduce the manual intervention. Okay, so like operations, we can perform with the configuration management tool. So that is why we are learning this Ansible. Okay, so once we done with Ansible, we will discuss about the cloud computing. Okay. So we have different types of cloud providers. So like AWS, that is Amazon Web Services, Azure, GCP. So nowadays, most popular cloud provider is AWS. Most of the organizations are implementing AWS. Okay, Amazon Web Services. So we'll discuss about Amazon Web Services also once we done with the answer. So here we will cover the different types of services. So we already discussed it, right? So these services we are going to cover: EC2, VPC, S3, EVS, RDS, okay, VBS, RDS, IAM, ELV, CloudWatch. So these services we will discuss. The Amazon Web Services. So in cloud computing, what we are doing is, so we are going to learn how can we create the required services. We have different services, right? So, so we have different services like EC2. So all these services, okay, we are going to create manually. We'll try to create these services manually. Okay, manually we'll create these services, and we'll see how can we work onto these services manually. Okay, now the same work, the same manual work we can do through the code also. With the help of the code also, we can create EC2 machines. Okay, with the help of the code, we can create VPCs, we can create S3 buckets, EBS volumes, RDS databases. So all these things we can create with the help of the code also. So if we want to work with the code, we have very popular tool that is Terraform. Okay, so what this Terraform will do is, Terraform is a infrastructure as a code tool. Okay, Terraform is a infrastructure as a code tool. So the required infrastructure we can get. Infrastructure means to required servers, required databases, required storage devices. Okay, required monitoring tools, load balancers, whatever we need. Okay, so these tools, these services, we can get with the help of the code. Just what we have to do, we have to write the code and we have to execute the code. Once we execute the code, the required infrastructure we can create. So for that purpose, we are learning Terraform. Terraform is a infrastructure as a code tool. So this Terraform will support all the cloud providers, most of the cloud providers. So if you learn Terraform, so you can work with any cloud, whether it is AWS or Azure or GCP. Okay, so you can easily work with any cloud providers. Okay, so that is why we are going to start Terraform once we completed cloud computing. After completing cloud computing only, we are going to start with the Terraform. Okay, so in the cloud computing, we are trying to create these services manually. In the Terraform, the same services we are trying to create with the help of the code. Okay, so here if we have code, so let us consider I need 100 servers. So if we want to do manually, okay, if I want to do manually, so I have to configure these 100 servers with a different that is different VPCs we have to use. So all whatever the configuration changes we need to do, so all the configuration changes we have to do manually. So which is a complex process to create the 100 servers. But if we are going with the Terraform, what we are going to do is we are going to write one script. Okay, in the script we are going to mention, so what is the availability zone, what is the VPC, okay, so what is the key pair we are going to use. So like that everything we can mention in the code to create the required 100 servers. And once we execute this code, our it is going to create 100 servers within a short duration. Okay, so like that it will reduce the complexity and increases the automation. So this is the Terraform is a infrastructure as a code tool. With the help of the code, we can provision the required infrastructure. Okay, so these are the tools we are going to cover. So this is the plan for the coming 2 months. In our 2 months of course, we'll cover all these tools. Any doubts up to now? Any doubts?
Hi, this is Sujit here.
Yeah, hi, Sujit.
Yeah. So the thing is, it's like kind of bottom line. It's like an administration, right? It's like there is no code involvement, like, or do you
Yeah,
need?
yes, yes. So DevOps engineer means we are not going to write any code. Just it
Okay,
is
okay,
like admin. It is like admin. Not
okay,
admin,
okay,
not the admin, but it's like the work will be like admin. So
okay.
what
So you
we are
think?
going to do is the main part as a DevOps engineer. Mainly, we are going to concentrate on CI/CD. Okay,
Oh,
this is
oh,
like a hard. In
okay.
this
Thank you.
CI/CD, what we are doing is we are going to take care of all the stages from development to deployment. That is our work.
Thank you.
Any more
And
doubts?
like,
Yes.
and like, I mean, what would be the schedule like? Daily the same time with how many days a week?
Yeah, 2 months. We need 2 months. The timing will be same timing.
So like it's like 7 days a week or like 5 days?
5 days, mostly 5 days. 5 days per week. We
So
will
it
get
will be
around
month.
45 to 50 classes to complete the
Okay,
course.
so it will be Monday through Friday, right?
Monday to Friday. If we miss the class
Okay.
on
Thank
Friday, we have class on alternate day like Saturday.
Okay. And one more thing, like for me, like it's like night, right? So do you like send them like
Yeah,
whatever the
recording
class fee,
also.
like
Yeah, at the end of
yeah,
every class,
yeah,
we provide the recording also.
yeah. That way, so that like in the morning, like once we get up, right,
Yes,
at least like we can
yes,
brush up.
yes, yes,
Yeah,
yes.
yeah, yeah,
Provide
yeah.
recording
Thank you.
also. And
Okay.
we'll provide notes also. At the end of every tool, we have different tools, right? For every tool, we'll provide notes also. Okay.
Yeah, yeah. Thank you. Appreciate it. Thanks.
Hi, this is Jyotsna. I have a small question.
Yeah, hi, George. Yes.
Yeah. So during the deployment stage, you told that so we deploy through images, right?
Yes, yes,
So using containerization tools,
yes,
we do that.
yes, yes.
So is it always the case? We are
No.
using just only
Uh,
the images, or
uh,
do we also deploy artifacts
yeah,
directly?
yeah, that's what we discussed. So we can directly deploy the artifacts. That is one way. We can use
Mhm.
images to deploy the artifacts. This is another way. Okay.
So
So if we,
we
yeah,
discussed deploying artifacts directly sometimes causes
yeah, issue. So this is the
problems, right, with
traditional.
the environments.
Yeah, this is the traditional way of deployment. Whatever we are deploying
So why
artifacts.
can't we adopt images like all the time?
Yeah. So due to the advantages with the containerization tools, so nowadays most of the organizations are moving towards the containerization. So if we are implementing containerization, so no need to
Mhm.
deploy directly. Yeah, always we are going to use images only for deployment.
Okay. Okay. Thank you.
So we have some other advantages also with the containerization, like in the production, whenever we need rollbacks to the previous version. That is, if we
Mhm.
got any production bugs, we have to immediately rectify that bugs, right? So if we are going with containerization, we can easily roll back to the previous versions. So like that, many advantages are. So due to these advantages, nowadays most of the organizations are moving towards containerization tools.
Okay. Got it. Thank you.
Any more doubts?
No, I'm good for now. Thank you.
Uh, Okay, we'll provide this demo recording also. Go through the recording one more time.
Sure. Thank you.
If no doubts, we'll wind up here. Thank you. Thanks, all. Thanks for joining.
Yeah. Thank you. Thank you very much.
Thank you. Thank you.
Thank you.